Hi class, in lesson 9.3 we will be solving one-step equations with multiplication and division. Learning targets for today, we will use inverse operations to solve one-step equations and again models to represent one-step equations. Let's take a look at problem 1 on page 626. We are maintaining balance, very similar to what we did in lesson 9.2. It says that each representation shows a balance. Determine what will balance one rectangle in each. Adjustments can be made in each pan as long as the balance is maintained. Make sure that you describe your strategy. So go ahead and do letter A and B for number 1. If I take a look at my answer for letter A and letter B for number 1, for my strategies, I divided the 9 squares into 3 groups of 3, and I can see then that 3 squares will balance one rectangle. Let's do the same thing for number 2 at the top of page 627. Again, we want to try to determine what will balance one rectangle in each. Adjustments can be made in each pan as long as the balance is maintained, and make sure that you describe your strategies. Go ahead and do letter A and B for number 2. If I take a look at letter A, I can divide the 10 squares into 5 groups of 2, and that will show me that 2 squares will balance one rectangle. At the bottom of page 627, number 3 says to describe the general strategy that you used to maintain balance in questions 1 and 2. And for number 4, generalize the strategies for maintaining balance by completing each sentence. So do number 3 and number 4, A and B, at the bottom of page 627. For number 3, whatever adjustment that you do to one side of the balance, you must make sure that you do the same type of adjustment to the other side in order to maintain balance. For number 4, letter A, to maintain balance when you multiply a quantity by one side, you must multiply the same quantity on the other side. For letter B, to maintain balance when you divide a quantity by one side, you must divide the other side by the same quantity. Let's take a look at problem 2 on page 628. We want to write an equation that represents each pan balance. These are the same pan balances that you analyzed for question 1 and question 2 in problem 1. Let the rectangle represent variable x and let the square represent one unit. Then describe how the strategies you used to determine what balanced one rectangle can apply to an equation. So in other words, again, what is going to balance x? I would like you to do letter A and letter B. Here is the equation that you should have for letter A. 5x is equal to 10. Creating 5 groups of 2 is just like dividing both sides by 5. So if you divide both sides by 5, you can see that x is equal to 2. Again, we are checking over our answer. If we substitute 2 in for the value of x, 5 times 2 is 10. 10 is equal to 10. The equation that we should have for letter B, 9 is equal to 3x. If you divide the 9 squares, you can get them into 3 groups of 3. If you divide both sides by 3, then you can see that x will be equal to 3. If you substitute in the value of 3 for x, 3 times 3 is going to be equal to 9, so 9 is equal to 9. For number 2, on the top of page 629, it tells us to check each of our solutions for question 1, parts A and B, by substituting your value for x back into the original equation that you wrote. So if we look at letter A, 5x is equal to 10. When we divide both sides by 5, x is equal to 2. And this is the part that we are looking at right here as far as substituting the value of x back into the equation. X is equal to 2, 5 times 2 is 10, so 10 is equal to 10. For letter B, same thing, 9 is equal to 3x. If we divide both sides by 3, x is equal to 3. When we substitute 3 in for the value of x, 3 times 3 is equal to 9, and 9 is equal to 9. Number 3 tells us to state the operations in each equation that you wrote for question 1, parts A and B, and the operation that you use to determine the value of x, and describe how they relate to each other. So much like we looked at in 9.2, this is very similar for multiplying and dividing. If we look at letter A in the original equation, that we see right here, 5x is equal to 10, 5 is multiplied by x. In order to determine the value of x, you are going to divide both sides by 5. The operations then again are inverse operations of each other. If you look at letter B, the original equation, you have 3x is equal to 9. In the original equation, 3 is multiplied by x. In order to determine the value of x, you're going to divide both sides by 3, and the operations are again inverses of each other. As we have previously learned, in order to solve an equation, you must isolate the variable by performing inverse operations. So we know that the inverse operation for addition would be subtraction, subtraction would be addition, multiplication would be division, and division would be multiplication. If we take a look at problem 3 on page 630, again, 2 different examples, and understanding that there is more than one way to solve these equations. Again, I will, whenever I am showing work, probably focus on method 1, but whatever method you are the most comfortable with, you can definitely use. So let's look at number 2 on the top of page 631. Consider the equations shown. State the inverse operation needed to isolate the variable. Then solve the equation, making sure that you show your work. Finally, check to see if the value of your solution maintains balance in the original equation. So go ahead and do letters A through D on page 631. If we look at letter A, we are going to be multiplying both sides by 4 in order to isolate the variable n. When we do that, 4 times 7 is going to give me 28, so n is equal to 28. And you can again see over here how you can check your answer when you substitute the value in for the variable. For letter B this time, you are going to divide both sides by 3 in order to isolate y by itself. Y is going to be equal to 6. When you substitute 6 back in for y, you can see that 18 is equal to 18. For letter C, we are going to multiply both sides by 4 and 3/10. When we do that, n is going to be equal to 40 and 42/100. Again, if we check our answer and substitute 40 and 42/100 for the variable n, we can see that 9.4 is equal to 9.4. For letter D, there's actually 2 different ways that you can do this. If you divide both sides by 3/10, we also know that dividing is the same as multiplying by the reciprocal, so you can multiply by 10/3. When you do that, y is going to be equal to 11 and 1/9. When you substitute that value back in for the variable, you can see that 3 and 1/3 is going to be equal to 3 and 1/3. Homework for tonight is going to be page 632, letters E through H. Remember that you need to make sure that you state the inverse operation needed to isolate the variable. Then you are going to solve the equation, making sure that you show your work. And finally, just like the word bubble says, make sure that you're checking to see if the value of your solution maintains balance in the original equation. That is going to be it for lesson 9.3 on solving one-step equations with multiplying and dividing. Please let me know if you have any questions. Thanks.